Welcome to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. Subject I am covering in my lecture series is microprocessor. Subject code is KCS 403. Today I will discuss peripheral devices, that is 8255 programmable interface IC, that is programmable peripheral interface, that is PPI 8255. So, what is the PPI all about? That whenever we want to interface any peripheral device with our microprocessor, we have to use this PPI IC. So, whether we are interfacing LEDs or switches or keyboard panels or ADCs or DACs, so we need this 8255 to interface the microprocessor with the peripheral device. This is the block diagram of 8255. So, this is the data bus buffer. This is read-write control logic, because sometimes you have to read the data and sometimes you have to write the data. So, we have to use these control signals to control the write and read operation. This is the reset pin. A0 and A1, these are the address lines. Here the group A control logic is present, group B control logic is present. Group A contains certain set of ports and group B contains certain set of ports. When we talk about the port, so 8255 have 3 ports, port A, port B and port C. Port A, B, C, all the 3 ports are 8-bit wide. Port A can be programmed in mode 0, mode 1 and mode 2. Port B can be programmed in mode 0 and mode 1 only, not in mode 2. Port C can be programmed in all the modes, but it is split into 2 parts. So, port C upper, port C lower. So, in port C upper, bit number 3 to 7 and in port C lower, bit number 4 to 7 and in port C lower, bit number 0 to 3. So, in this way, port C is split into 2 parts, port upper and port lower. So, it can be programmed by set reset operation. Group A and Group B control. So, Group A control consists of port A and port C upper part, and Group B control consists of port B and Group C lower. Data bus buffer, it is 8-bit bidirectional data bus. It is used to interface 8255 data bus with system bus. Internal data bus and outer pins are connected internally. Direction of data buffer is decided by read or control logic. Read-write control logic, this is getting the input signals from control bus and address bus. Control signals are read and write. Address signals are A0, A1 and chip select. 8255 operation is enabled or disabled by control chip select signal. This is the pin diagram for PPI. Here the port A is shown. This is read, this is port A. This is read signal, write signal, chip select, reset, ground. Now A0, A1, these are both the address lines. D0 to D7, this is the data bus buffer. VCC, this is port C and green, the port in green is port B. So, I have already discussed that data bus is 8-bit bidirectional buses for transferring the data. Chip select is active low signal. When it is low, the data is transferred from microprocessor. Read, this is active low signal. When it is low, read operation will start. Write, it is again active low, and when it is low, write operation will start. These A0 and A1 are used to select the ports. Like if A0 and A1 is 00, then port A is selected, 01, then port B is selected, 10 is PC, 11 is control register. Reset, it is used to reset the device, that means clear control registers. PA0 and PA7, it is 8-bit bidirectional input output pin. It is used to send the data to peripheral or receive the data from peripheral. So this is port A. Port B, it is again 8-bit bidirectional input output pins. It is again used to send or receive the data from peripheral devices. PC0 to PC7, this is also 8-bit bidirectional input output port. These lines are divided into two groups as already discussed, PC upper and PC lower. There are two operating modes, bit set reset mode. Here the port C can be set or reset by sending out instruction to the control register for the port C. Now input output mode, there are broadly three modes. So mode 0, mode 1 and mode 2. So mode 0 is simple input output mode, mode 1 is handshake mode and mode 2 is bidirectional mode. In simple input output mode, port A, B acts as the simple input output ports. Port C can be split into two parts, port C upper and port C lower. So these two make group A and these two make group B. So here outputs are latched, inputs are buffered but not latched, and ports do not have handshake or interrupt capability. So here no handshaking is required. Mode 1, input output with handshake. In this, input and output is transferred by handshaking signals. These are used to transfer the data between the devices whose data transfer speed is not same. So in this mode, port A and port B use the lines on port C to generate or accept the handshaking signals. So here in mode A, port A and B are used as the simple input output mode, but port C, 3 bits each of port C, upper and lower, are used as the handshaking signals for port A and port B respectively. So bidirectional input, mode 2 is bidirectional input output data transfer. It provides a mean for communicating with the peripheral device or a structure on the single 8-bit bus for both for transmitting and receiving data. So single port A is used, and lines on port C are used to generate or accept these handshaking signals. So 5 lines on port C, 5-bit control port, that is port C, is used for control and status of the 8-bit bidirectional bus port, that is port A. So in this way, in this mode, port B is not used, only port A and C is used, and 5 bits of port C are used for handshaking signals. Input out, now we talk about the modes in details. This is the control word for mode, input output mode. So when we talk about the control word, so in using the control word only, we can configure the device in the particular mode. So when we talk about the input output control word, so this bit is 1 for input output mode. These 2 bits define the modes of group A. Group A modes. So here, since group A works in both all the 3 modes, group mode 0, mode 1 and mode 2. So when these bits are 0, 0, it defines mode 0, 0, 1 mode 1 and 1, 0 is mode 2. Now we come to this bit. This is defining the status of input or output status of port A. So if we are, if this is, so this is group A, so this is port A. So if this is this port A is input, so it should be 1. If we want to configure port A as output, this should be 0. Now this D3 bit defines the status of port C upper part, upper nibble. So if the port C upper nibble has to be configured as input, so it should be 1. If it has to be configured as output, then it should be 0. Now this completes group A. So till here it gives group A configuration. Now these 3 bits defines group B configuration. So D2 bit defines the mode, 0 here defines mode 0 and 1 here defines mode 1. In D1 it defines the status of port B. So 1 here defines the port B as input and 0 here defines port B as output. Here this mode defines the port C lower nibble configuration. So if we want to configure the port C lower nibble as input, we have to give 1, and if we want to configure it as output, we have to give 0 here. So this is a control word for input output mode. Now we talk about the bit set reset mode for control word for bit set reset mode. So we all know that for bit set reset mode only port C is used. Here first bit is 0 for bit set reset mode. These are don't care, so they can be by default taken as 0. These 3 gives the bit number. So if we want to configure bit number 0, then we have to give 0, 0, 0. If we want to configure the bit number 1, then we have to give 0, 0, 1. So in this way all the 8 bits can be selected by these 3 combinations. Now this defines that whether we have to set the bit or reset the bit. If we want to set the bit, then this should be 1. If we want to reset the bit, then this should be 0. For example, if we want PC3 is set, then control register will be what? So this will be, if we want to set the PC3, so 0, 0, 0, 0, or we can take don't care also. Then 3 is 0, 1, 1, and this is, if we want to set, then this should be 1. In this way we can set PC3. If we want to reset PC4, what will happen? 0, 0, 0, 0, and we are talking about PC4, 4th bit, 1, 0, 0, and this reset 0. So this gives the 4th bit. So in this way we can configure any of the bit of port C. Let's have a look at the problems. We will solve a problem, so we will be able to understand the use of 8255. So this is saying that write a program for IC 8255 to read DIP switches and display the reading from port B to port A and from port CL to port C upper. So now, as you can see from the figure, this is 8255, this is port B, so this is port B. So at port B switches are connected and at port C lower switches are connected. So here the switches are connected and port C lower, PC0 to PC3 switches are connected. So what we have to do, that this device has to read the value of the status of the switches. Corresponding to this status, it has to change the status of LEDs. And where are the LEDs connected? LEDs are connected at port A and port C upper. So what it is saying, that the status of the switches connected at port B should be obtained at port A, and status of the switches connected at the port C lower part should be obtained at port C upper part. So now we will solve it. So given it has given some addresses, port A address is this, port B address is this, port C address, and control register address is this. So here we have to understand that which ports are the input ports and which ports are the output ports. Now port B and port C lower are the input ports because they are reading the status of the switches. Now port A and port C upper are the outputs because it is giving the status of, it is showing the status of switches with the help of these LEDs. So whatever the data is being read from the switches, it is being reflected on the LEDs. So here LEDs are the outputs. So it is playing the role of output. Now we will find the control word for this. We are using input output mode, so this bit will be 1. These two bits show that what will be the mode for group A. So the mode is 0, since we are not using any handshaking signals, simple input output mode is used. So this will be 0 0 for mode 0. This bit will show that what will be the status of port A. Since we know that port A is used as the output port, so for output port this bit will be 0. Now we talk about the port C upper. We know that port C upper is again output port, so this will be again 0. Now we come to this group. This is group B. It is again acting it is being configured in the mode 0. So here again this bit will be 0. This bit will tell the status of the port B. Since port B is used as the input port, from this diagram we can understand there's on the port B switches are connected, so it is acting as the input port. So here this bit will be 1. And now port C lower, it is again input port because switches are connected to this, so it is again input port. So in this way we obtain the control word. You can group these 4 bits and group these 4 bits to obtain the hexadecimal equivalent, and it will give 83H. So this is the control word. Now we will write the program for this. First of all, whatever we want to store at the output port, it has to be stored in the accumulator first. So now we transfer the control word in the accumulator. From the accumulator we can store at the port address using STA 8003H. We could have done it using the port using the out operation also, out instruction also, in case of the byte size of address. Now again, so in this way we have sent the control word to the address. Yes. Now we are loading the accumulator with 8001. What is 8001 here? So it is the port B. So port B is input port. So we are reading the status of port B using this instruction. So here the status of port B, because this is the port B address, the status of port B is being loaded into accumulator. From the accumulator it is being copied to, it is being moved to port A. So the status of port B is being sent to port A. So whatever is the status of the switches on port B, it will be reflected on the LEDs connected on port A. Now again load LDA 8002, that is, it will load the accumulator with the values corresponding to port C lower. So this is the address for port C lower. So whatever the values have been obtained at the port C lower, it will be saved in port A. It will be saved in accumulator. Now the C, whole C, this is representing the port address of C, upper and lower both. Yes. So now accumulator is holding port C status, 8-bit status. But what we had to do, we had to represent the port C lower status on the port C upper. We had to do this because the LEDs, because the switches are connected to port C lower and LEDs are connected to port C upper. So we have to transfer the status of this port C lower to the port C upper. Now we have obtained the whole port C in accumulator, but we are concerned with the values of port C lower only because switches are connected here only. So what we will do, we will AND this whole data with 0F. So why we are performing this? We are masking this part. So this part is being masked. So after the operation ANI 0FH, what will happen? This part will be 0 and this part will be obtained as it is. So port C lower part will be obtained as it is and upper part will be 0. Now we are concerned with port C lower because we want the status of switches. Now we will rotate this left 4 times. So after rotating this data 4 times in the left direction, we will be able to get the data in this form. So we will be able to replace port C upper with the port C lower value, and the lower 4 bits will be 0 0 0 0. So in this way we have obtained the value of port C lower in this. Now we will copy this, we will move this value to the port C upper. So when we will move this value to the port C upper, obviously port C upper will get the value corresponding to port C lower. So using this instruction, we will store the data available at accumulator. At this point the data stored in accumulator is this. So we will store the data available at accumulator at this address. So this address is corresponding port C upper. So in this way port C upper will be reflecting the status of switches connected at port C lower, and the port A will be reflecting the status of the switches connected at port B. So halt will end our program. In this way we are able to interface the LEDs and the switches using 8255. That's all for today. Thank you.